Okay, we have a MacBook Air. This is 15 inches, A1466. Description is dead. As you know, with no power devices, the first thing we want to do is take the board out. We do not plug power to it. We confirm the state of the board before we plug power to it. This is important, especially if you are in the dark, concerning the state of the board. It's important you have a better idea what the board what stage the board is in, so you do not cause more damage to it. So quickly, we're going to take the board out and then take the back cover out and then continue from there. Okay, so what we're looking at, the board looks pretty clean. With the JTEC connector, that means this is a 2015-2017, given that it's a small JTEC connector. Yeah, so let's disconnect the battery, and then there's a connect charger to it. Now, because we can see that the device is uh clean, so we don't really have to worry about potential damage. We don't see any sign of liquid ingress. So let's quickly check for any possible short before we continue. Multimeter and continuity mode, black probe to ground, and then red probe. We see a bit of oxidation by the PP3V3 regulators section. We're not sure if that's a point of concern. We will definitely come back to that. But first and first, okay, yeah. For now, let's not worry about that. But we'll definitely that's definitely something that we'll have to worry about. So having confirmed we don't have a short, we connect our charger. There is no charger LED. Okay, is it because our charger is not properly plugged in? Okay, nothing. Okay, let's try again. And still nothing. Okay, let's see what we have on our PPDCIN, shall we? Do we have any voltage on the board? PP bus is 0 point something. Okay, let's see. Do we have PPDCIN? PP3V42 is definitely going to be required for our PP bus to be generated. So let's see. What do we have on our PPDCIN? Okay, we definitely have power going onto the board, but we do not have PP bus. It's PP3V42 is 0. Okay, that's interesting. So yeah, we PP34280. So we definitely have to take the board out. So let's quickly open up the board view to give you guys an idea. This is going to be an 820-00165, and the section we are looking at, it's the PP3V42 regulator circuitry. We did confirm that we do not have PP342, and that section of the board also, which is R7095, has a bit of a moisture. So we are going to be looking into that. And the inductor, which is L7095, we were expecting to get 3.42 volt there, but we are getting 0. So this we will be coming back to R7095, but it doesn't really seem like that's going to be our issue, but it is worth noting. So the first and first, we confirmed that we have PPDCIN. uh, let's just let's have that confirmed again, that we have PPDCIN. And then yes, PPDCIN is present at 16.6. That's present. So we're not expecting to have LED because the IO board cable is disconnected. But even when we had the IO board cable, there was no LED on the charger. Okay, so let's see. Do we have so we have PPDC in, and then we have PPDC in going onto the board up until the point of the voltage in for the PP342 regulation, which is U7090, but we do not have PP3V42. So let us go to D7005. We're expecting to have PPV in, so that is voltage coming into the chip to create PP3V42. So PPDCIN is gonna go through D7005. D7005 has two outputs, has two inputs, one input from the battery and then the other one from the charger. So let us see. So I'm actually having two dedicated multimeter. One it's permanented on continuity mode for measuring for a quick short, while I use the other one for my voltage as well as a diode mode measurements. Okay, so again, let's see what do we have on our PPDC in at the output of the inductor. We are getting zero, less than what we get at the input. So let's see what do we have across the resistor, because let's basically disconnect the Wi-Fi antenna cables. So we are getting voltage into D7005, but we're not getting anything out. You see, we're not, okay. PP342, it's zero. Okay, and that's we're supposed to be getting PPDC in voltage across the diode, but so let's see what we have across the resistor, which is R7005, because we have PPDC in PP342. It's definitely zero. Let's see what we have on. Okay, on R7005 we have in voltage 16.6, but we have 0.3 on out, so which means we have an issue after R7005. And so we know the issue, it's not going to be from it's not going to be from the diode, because the diode has no paths to ground. So but definitely something, it's pulling the voltage to ground. So or something is preventing the voltage from flowing through. So what we are going to do is we are going to find a way to isolate the issue by, so first and first, let's quickly take the board out. And by the way, for this you need a T5. For the back of the machine you need a P5. And then when the back cover is out, you need a T5 for the screws inside. And the design of the 2017 2015, it's pretty much the same as the 2013 2014 2015 in terms of parts replacements across them. You can literally replace the parts. I mean, but then when it comes to, for example, programmed components like your SMC. Oh, by the way, so your okay, I'll talk about that later. So like your SMC, you have to make sure you SMC between 2015 and 2017 works. SMC between 2013 and 2014 will work, but 2012 stands alone, and then 2011 also. So you cannot use the SMC for 2011 on the 2012. So SMC for 2012 has to be 2012. SMC for 2013 will work on it 2014. SMC for 2015 will work on it 2017. Okay, our board is out. The next thing we want to do now is we want to try to isolate our issue. We do know that we have voltage at the beginning of the resistor, but we do not have voltage out. So the next, what we want to do now is we see also the other side of the board is pretty clean. Yeah, it's pretty clean. We can give it a bit of a dust. Yeah, the other side of the board is pretty clean. The only section that seem to have a bit of a concern, it's the section of the PP3 water regulation circuitry. In any case, let's first try to isolate the issue, which is to understand why we have voltage in, but we don't have voltage out. So we are going to remove the diode, and then obviously we do know that the diode is basically creating is basically a bridge. It's not like the diode itself it's a problem, but we just want to see if the problem is before the diode or after the diode. So that's why we're taking the diode out. Not that we're not taking the diode out because we suspect the diode to be the problem, but we're taking the diode out because the diode is it's more like a bridge. So we want to be able to isolate if the issue is before the diode or after the diode. So now that the diode is out of the circuitry, let's now we would again put power to the board and then see what happens to see if we have issues. If we still have issue, then it means the problem is before the diode. But if we don't have issue, it means the problem is after the diode, which is basically the output of the diode. So let's connect our charger. This is confirm that we have PPDCIN voltage. There you go, we have PPDCIN voltage by the resistor. Okay, that's fine. And then outside the resistor, wait, in, yes. So we have, wait, what's that? Okay, yeah. So we have voltage in the resistor and then we have voltage outside of the resistor. So our problem is definitely after the diode. So our problem is after the diode. So now we want to, so after the diode we have so all of the points that are connected. So let's start by removing U1790 because our problem is going to be after the diode. Although U1790 looks pretty good, but yeah, let's see. It's one of the component on the line of the diode output. So we're gonna put back our diode and then remove U1790 to see if that is our problem. So basically what we're trying to do is we're trying to narrow down our issue to the component that is pulling down our voltage. So let's quickly put back the diode. Okay, so after we now let's remove U7090. That's the actual PP3 photo regulator IC. So let's put that aside, and now let's see if we now have so if we have output from the diode now, it means our problem is U7090. But if we don't, um, it means a different component that is attached on the same line. It's our problem, and we're definitely going to come back to C90, C7095 as well as R7095. But right now, let's get our voltage. Let's get our voltage up and running. Let's get output on D7005. So U7090 is out of the circuitry. Let's see if we have a different reaction on the board. Do we now have output on our diode? Let's see, what do we have? So input is it's 16.6, and we still have less than what we expecting on output. Okay, so it means our problem it's not U7090. So what else is on that line? Okay, so we on that line we have C7092, we have C7091, C7090. Okay, so let's try, and also we have now that shouldn't be something of a concern now. So let's try. Let's first of all, so U7090 is out of circuitry, but now we have C7092 as well, and then on the other side, there's nothing that is on the line. So let's stick on the C7090 first. C7092. Let's stick on that first. That is a tantalum capacitor, by the way, and also which also means that it is a polarized capacitor. in replacing a tantalum capacitor, you have to make sure that the polarity it's right, just like every polarized capacitor, every polarized capacitor. So let's remove that. That is out. Now let's put back our U1790, because definitely that is not our problem. Let's put that back. But before then, let's see if we have anything different now. Let's see, do we have output on our diode? See that 16, and then yeah, it's great. Now we have output. We now have output on our diode. So definitely, so our problem was definitely the tantalum capacitor. So we have to put back our regulator and then get another cap to replace it. So we don't have to replace the U79, the PP340 regulator that we took out. So we are only going to replace the cap, as that is our only problem. Meanwhile, the other two components, the capacitors and the capacitor and the resistor, that was looking funny, we are going to remove those as well. Even though they are not a problem now, they may become one in future. So we may kind of do like a preventive repair. So so yeah, we're also going to replace those two. So I'm talking about C7095 and R7095. So they're not really a problem now, but because of the oxidation, because of the way they're looking, we might as well just replace them now to avoid having to avoid them failing in future. So now let's get a donor board to replace our tantalum capacitor. Alhamdulillah, this was a pretty straightforward repair. Sometimes you get repairs that are very straightforward like this, and then other times you get very tedious repair. Okay, so yeah, the ones with the PCH issues, which would obviously uh, okay, yeah. So let's quickly replace the cap, and we should be good to go. I have to get another one. Let's get another wood. And that works. By the way, you can it doesn't have to be a 2017. As you can see, I'm actually using a 2013 2014 board, but this is not a chip that holds a particular a program on it, so you can definitely use it. It's not like an SMC, for example, which if it was the case of an SMC, you definitely have to use the same thing. So I'm basically moving over the three components: the tantalum capacitor, which is polarized, and then the resistor, as well as the capacitor. That looks a bit funny because of oxidation. Mm, okay, that's pretty. That's good. So the next thing we want to do is give it a bit of time to cool off, and now see what we get. We are hoping that by now, we should be having PP3V42 generated, because I mean before now we were not having that, and that was because of we were not getting voltage in. So voltage out of from the diode, the voltage that goes into, we were not getting anything out. So let's quickly clean the board while we're giving it also time to cool off. And this it's pretty much seem like the only region on the board that's of concern, and which is the PP3V42 regulation circuitry, which is the region for the PP3V42 So I mean, the PP342 is pretty much it's your most which is the second most important rail on your machine after a PPDCIN, because most of the secondary rails or even some of the very primary rails are generated from the presence of PP342. So if you don't have PP342, as you guys can see, you almost not gonna go anywhere. And then the G3H, which is basically means hard, G3 hard, which means that rail has to be present at all times. So but in this case we don't have it, so we want to make sure that that rail it's resolved first before we can do anything else. Now with the rail resolved, we're pretty much sure that the issue is fixed. So let's just quickly clean our board and then we can test it. I mean, also giving it better ample time to cool off. Let's clean the board and then the other side as well. I like to make sure that my boards are clean. Okay. Just quickly clean our desk a little bit. And then we are now going to see what is it that we, yeah, so I'm not gonna I like to have the fan unplugged. I want my multimeter to do detailing. I don't want to um give myself heart attack expecting to see a fan spin. So I usually do not like to see a like I don't want to, I don't want to be kind of expecting to get a fan spin and then I don't get one. So I don't want my multimeter to do detailing for me. Now when I am certain that now I have the voltage required for me to get a fan spin, especially now that I realize that the board is in SO state, then I can connect the fan. So PP342 is now present. All of the rails that we require are present. But let's see, what do we have on our SO rail? That's our PP bus rail. Good. What about our SO rail? What do we have? A zero. What's happening? It's not supposed to be zero. Let's check that again. SO rail is zero. We're checking. PP bus is still at L7520. Okay, let's see, what do we have on C31 8130, which is PP3V3 underscore S5. Yeah, I guess the DC jack. I suppose we had one DC jack that was not working. I suppose that's the one that I'm actually using now. Let's just get a different DC jack. Let's see, what do we have now? Do we have something different with a different DC jack? Because I definitely know that one of the DC jacks that we have on my desk, and I must make sure I discard it this time so that I don't make mistakes with it. 3.4 volt, PP bus is 8.5, and then let's see, what do we have on our SO? Let's see, and then let's see, what do we have on our SO? That's PP bus too. Yeah, that's it. So we now have a 5 volt. So definitely the DC jack was a problem. Yeah, so I need to make sure that I destroy it so that I don't make mistake of reuse, because I mean you don't have a DC jack that fails on your desk and then you obviously use that and then you would base your troubleshooting on that based on the result you get from it. So it's better that I find a way to make it unusable so I don't make the mistake next time. Because I really I mean this was quite easy for me to pick up, because I remember there was a DC jack that was, imagine if I didn't know that the DC jack itself it's a problem, so I would keep troubleshooting the device thinking that my problem is not resolved. Okay, so now we can now connect the fan, because now we confirm that we are in SO state, which would mean that our device is practically powering on. So let's connect the charger again. It's looking for that beautiful fan spin. And there you go, that's a beautiful fan spin. By the way, you should expect that slight delay. That is only the case of an original Apple charger. If you're not using an original Apple charger, that delay will not be there. So let's now put the board in the shell and expect to see a beautiful Apple logo. So let's quickly put the board aside, and then we want to put the board. So we're only going to connect the cables that we need just to get to see that we actually, because it's one thing for the board to power on, is another thing for the board to post. So getting an Apple logo will basically give us all of the answers that we need. So we're not necessarily going to have all of the cables connected. We would just be connecting what we need. Okay, let's see. Do we have a beautiful Apple logo? Do we have a fan spin? Yes, we have a fan spin. And then what about Apple logo? Let's look for that Apple logo. And that's it. That's a beautiful Apple logo. Yeah, so we're not interested in the device booting. Yeah, the most important thing is that now the device is working. So we had issue with PP342 regulators regulator circuitry, and that was because of we were not getting voltage out. We were not getting voltage out of our diode, and we eventually, even though we were suspecting C7095 and as well as R7095, it turns out that that's not our problem. And our problem was actually C7092, which was pulling down our pulling down the voltage at the output of our D7005. So even though during our troubleshooting we also remove U7090, U70 wait, is that U70? Yeah, U7090. And because we're hoping that that's our problem, but that's not our problem. So yeah. Yeah, and we eventually found that our problem is C7092, and then after we removed it, our problem was solved. Yeah, I hope you guys really learned something on this one. This is quite uh this was quite simple, alhamdulillah. And it was basically short and sweet. I will say it wasn't such a long video, and we didn't have to address multiple issues. We only had to address the issue of PP342. Thank you guys. I'll see you.